All right, let's get started. Good crowd. Come out and talk about NiFi and OCR right at the end of the afternoon. You guys are troopers. Thanks a lot. So today, my colleague and I are going to talk about scalable OCR with NiFi using Tesseract and ImageMagick. So my name is Casey Stella. I'm a data scientist on the Apache Metron project. Before that, I was a data science consultant and architect in the Hortonworks Professional Services. So I've seen this use case a lot. It comes up quite a lot from the field. So I thought that since I've implemented it a few times, and a number of people that I know of have implemented it a few times, it would be nice to have a nice reference implementation of this out in the open source. Michael, I'll let you introduce yourself.
Yeah, so I'm Michael McClavick. I've been with Hortonworks for a little over 3.5 years now, and I'm also now an engineer on the Metron team. Came from professional services that I did for a while. So yeah, so that's a little bit about me.
Okay. So the problem, as you probably have heard from us and Gartner and lots of different people, is we have a lot of data. And it's growing aggressively. In particular, unstructured data is growing aggressively. But really, is it unstructured, right? It's not really unstructured. It's actually semi-structured, right? Most of this data is text. A lot of this data is things like forms and documents and emails and stuff like that, right? Stuff that we should be able to crack out of these, of the images that they're held within, right? So this appears to be the case, aggressively inside of the enterprise. I see a lot of this, right? Where they do things like, well, we took a picture. So we hired a bunch of people to get really crappy iPhones and take really crappy pictures of documents, and then we put them somewhere, and then we forgot about it for a few years. And now we want to extract insights out of that, right? So this is a common use case. You'd be surprised. There are also other use cases that you have more globally, right? And there's a lot that we can do to extract meaning out of this. NLP is fantastic for it's extremely mature and extremely rich in terms of being able to pull out the relevant information from this sort of free-form text. And also simple analysis gives us it gives us a unreasonable amount of insight. Just very, very simple analysis, I found. So OCR really enables us to extract textual information from images in an intelligent way. And on top of this, we have pretty mature platforms for doing this, right? Tesseract is an open source platform for doing OCR that has been around forever, open source by Google. We have mature image processing pipelines that have been around forever, but we don't really have them pieced together inside of Hadoop, right? And that's what this talk is going to be about, piecing them together. So first, let's motivate the problem a bit. So I've motivated it kind of vaguely, but I'll motivate it more specifically. So I want to talk about one use case that I've seen I've seen this successfully be done at. So the problem is radiologists make notes, right? And they make notes about patients. A radiologist is a human, so when a radiologist gets an image, they look at them and they say, okay, this person has calcification of the aorta, they have heart disease, right? They also might have a lung nodule, because when you do a chest CT, you're going to get all of the chest, right? The doctor may be looking at for a specific thing. They sent the patient there for a specific thing, and they may not understand, or they may not entirely pull out the pieces and the hint at the secondary diagnosis. So what we were trying to do was say, hey, look, let's find diagnoses that doctors missed. Let's make this data pipeline, analyze radiologist report, and bounce it against what was being claimed, which diagnoses were being claimed, and see if we miss anything. And it's great for the patients, it's great for the insurance companies, right? It's a fantastic use case, and it works very well, right? But these radiologist reports were scans of really bad scans. So the first piece of that is an image scrubbing, or extraction of the pages, image scrubbing, and extraction of the text, right? And I'll point out, okay, as a working data scientist, this is the correct place for advanced analytics. In the loop with humans, looking after, making sure that we didn't miss anything, right? So the other case that came up recently is journalists are now being asked to analyze huge volumes of data, right? You look at the Panama Papers alone, it's 2.6 terabytes of data. And there was a really great Forbes article about all of the data munging and data management. So for a data nerd, this is a great article. I don't think most of the rest of the world was particularly interested in, solar pipelines and stuff like that. But it was great. It was a great article. But the first thing they had to do was take these documents, extract out the text from it, and then they could go about the hard work of analyzing the image. But until you get these documents, until you crack that nut and get at the actual meat of the text, you're not going to be able to do much with it, right? So it's a tool to enable better journalism. And this is where journalism is going, I think, in the future. Okay, so methodology. So we'll talk about, there's 3 different individual steps. Conversion, taking a PDF, splitting it out page-wise into TIFF files, and we're doing this with GhostScript. Right. There's pre-processing, and I've seen a lot of solutions that completely skip this step. I think, well, just pull this out, throw it to Tesseract. Tesseract, give me some gold, right? You almost always need to scrub your documents because people take images. Literally, the radiologist report use case, we literally had people with like an iPhone taking pictures, and they were rotated, and it was grainy, and someone's thumb was over it. It was terrible, right? You have to have that text cleaning pipeline, and then being able to hook into Tesseract. So for the text cleaning pipeline, I'm a particular fan of ImageMagick for this, and we'll talk about that in a minute. In fact, we'll talk about it now. ImageMagick it's a standard open source library for those of you who don't know. It does rich and very robust image processing on the command line. So most people who are using it I would deem them as expert users, much smarter than me for doing this kind of stuff. It's great, right? There's a large and mature community of users. It's been around for years. It has all the primitives that you could ask for in terms of image preprocessing. You can do all the stuff you need to do. The problem is it's confusing as hell. For the novice coming in, it is very hard. Like so from a business perspective, I want to integrate with it. I want to have my engineers work with ImageMagick. There's some doing, man. You've got to figure this stuff out. It's hard. So it can be a daunting task, frankly, and very arcane. But ImageMagick's community really comes to the forefront. This is my favorite part about open source, right? Community, even if you have an arcane product, Hadoop, if you have a community around it, you can build amazing pipelines. You can build amazing solutions. So what they've done is the community's gotten around this and built layers on top. They use ImageMagick primitives as primitives for sort of domain-specific things. And Fred Winehouse did this for text cleaning. Great scripts. If you see most of the Stack Overflow questions about people saying, I have license plates, so I need to scrub this data. A lot of people say use Fred scripts, right? So what we did was, so I could use Fred scripts, that would be great. But what I really wanted to do was I wanted to expand on Fred scripts, right? I wanted to make this so that we could expand Fred's stuff, because Fred's stuff hasn't been really managed since 2013, from what I can tell. So what I did was I ported we ported the interface over to Java. And it's still calling ImageMagick underneath the hood, right? But it allows you to plug in different types of operations, right? It's a little bit more pluggable. So it currently supports, amongst other things, unrotation, which is huge. Straightening of images, that's the really big one. Like just straightening images, if you fix that alone, you get a much better idea. And an automatic unrotation, right, which is huge, up to around 5 degrees, right? You get binarization, so converting to grayscale in an intelligent way. You get enhancing brightness and smoothing, like adaptive blur, all of the nice things that you would kind of want for general purpose image preprocessing. So this is an example. You'll notice this is a picture. This was run with the utility. This is the input was from the Fred's text cleaning script. And you'll notice it's rotated, right? You pass that through Tesseract, Tesseract's going to barf all over it, unfortunately. I've seen the aftermath. You rotate it a bit, and you grayscale it, and you enhance it a bit, right? So even now, it's a little bit arcane, as you see from the arguments. But it's a lot better than what you would see with the actual ImageMagick script itself. OK. So I'll let Mike talk about the methodology for how to scale this out.
So what we chose to do, so NiFi ends up being a great tool for being able to put this into a pipeline. So what we've done, Casey talked about the different steps in the processing. So what seemed very natural here was to be able to pin these up as custom processors within NiFi. So what we've done is put together a pipeline basically using this functionality exposed as processors through NiFi. It's really easy to use, and of course it's very customizable. And some of the nice things that you get, you get the data provenance throughout your pipeline, which is really, really nice. So as we pull these PDF files into the system, and we split them off into their separate page-wise TIFF files and do the extraction, we can see exactly what happens to each and every file that we pull into the system. We get the full, your data provenance or lineage for each of those files that comes in. It's really, really easy to use. So once we drag these processors into the NiFi UI, if any of you have used this before, it's like really, really nice and simple to use. The help documentation is all right there. Part of what we have introduced with our processors, documentation about what the different properties and custom properties you can provide, including the ImageMagick properties, all shows up as part of the UI. So it's really, really nice. In addition, each of these processors that we expose through NiFi, what we're going to show you is a very simple example of a pipeline or workflow that you can expose through NiFi, but there's no reason you can't extend this and do other things with your workflow. So this is, to the point here, what we're going to do is actually work through some of the Hillary Clinton emails and just kind of show you how that extracts out. So there's some interesting things in there.
This is a non-political talk, I assure you. We just needed some PDFs, and I actually had to read a lot of Hillary Clinton's emails, so if anyone has questions, I'll answer them after.
She likes roses if you want to send. OK, so up on the screen here, I have a screenshot basically of our NiFi workflow. So what I did is we're pulling in, we have a directory just on the local file system. OK? And so what we do is we pull that in, we do the conversion. We split off two different directions here. What we want to keep, as always, we want to keep the raw data. So regardless of what kind of processing we're doing, we never want to get rid of the original files. So you have your provenance within NiFi, but also we're dumping these off into a location in HDFS. So if we want to go back and do other things with them later, we can certainly do that. So we have a HDFS put that we're using there. In addition, we're splitting off and customizing some of the attributes that we have off of the file. So we get in a PDF file, but again, we're splitting this off into multiple pages. We're converting it to TIFF and splitting it off into multiple pages. So we want to be able to pull that data and kind of drag that in as we do the extraction and drop the final result into HDFS as well. So again, we have the conversion process, which again, that extracts out the TIFFs. We have the pre-processing, which does the unrotation as well as the grayscale that we showed you before. We do some updating of the properties, and then finally we have the actual Tesseract OCR that is done prior to finally putting this data onto HDFS. So just to give a kind of a logical layout of what actually happens to a file as it flows through, it's really, really pretty simple. So the conversion, pre-processing, and extraction, each of those are the processors that we expose through NiFi. So you'll see again that we have a couple PDF files there that have a couple pages each, and they get split off into separate pages, and finally they get dumped into a location on HDFS where there's a directory basically per PDF that we pulled in, and then you'll have multiple files for each of the pages. So let me show you a demo here. Where is it? Is that readable? That does not seem readable. Let's see if we can fix that. Ta-da. Technology.
It's hard. NiFi doesn't solve that.
So what I'm showing here is the HDFS location. Yeah, the HDFS location. I already at this point kicked off the process. So what you're going to see here is the raw data. I'm going to show you as the data comes through, there's a process directory. So I'm logging out attributes. You can see there's a PDF file along with the text file that is extracted out from that. I'm going to go back into the actual HDFS directory here. So we had a couple files before in the process directory. There should probably be one or two more now.
The important thing to note here also is that it's very configurable.
So,
yeah, go ahead.
Actually, so here you can see here, there's apparently some correspondence about Benghazi, actually, in this particular case. So this is text that we extracted. Again, this is a single-page document here. We extracted out of one of the PDFs. This is, again, going through our NiFi pipeline using Tesseract. And again, that's including some of the cleanup that we did with the prepping with GhostScript, as well as the work with ImageMagick there. So you can see as the process continues on, we've got more and more files that are being dumped out here. I think in this case, so we had a single PDF with multiple pages to it. So here we've got a couple files in the text that goes along with those as well. So again, the beauty of this is, for the sake of our example here, we're just dumping this off into HDFS. It's really easy to view with the Embari views here that we have, but there's no reason you can't publish these results to other places as well. You could publish the Kafka queues, whatever you want to do. If you want to get into doing NLP type of work, other type of machine learning, that kind of thing, there's no reason that this can't feed that type of pipeline for you. This is fairly CPU intensive, so this is where using something like NiFi ends up being very nice. The architecture around that versus what you might do with typical MapReduce and HDFS is a little bit different. Underpinning this, you might consider RAID technologies underneath for your serving store for the actual hard drives that you have. So I think that is it.
Okay. So I'll echo one thing there is the healthcare use case that I talked about before, that was written in MapReduce. Right, it was a long time ago. Right, the original impetus for this is written in MapReduce. This is so much nicer. It's so much more configurable in the sense that I was constantly finding myself in a situation where I need this, and then this other thing that I need to go back and add to the MapReduce code. And this was just so much more of a cleaner abstraction. I just want to point out. It's been a real pleasure because I've written this in MapReduce and in Pig. I even tried to do it in Hive once. It's bad time. So providing this kind of utility it's a necessary step. Unfortunately, I like at the end of all of my talks to give bad news. Like before, it was all the good news. Now here's the gotcha. Right? It's a necessary step, but it's really not sufficient. Right. So providing it, so what happens, the problem with Tesseract is it's not going to handle human handwriting, right, as of yet. We're going to, hopefully, if you went to the Google talk, if they can figure out how to classify a cat image, surely they'll be able to figure out how to classify some handwriting. Right, so eventually that'll happen, but it's not there yet, not right now. But the real problem here, and I think that's actually okay, right? We're still able to get a lot of data. And a lot of data is textual documents that are typed. But kind of the really bad news is, even with good image preprocessing, errors are going to creep into the documents. And the really bad ones are the kerning errors. These are coherent errors. Like RN looks a lot like M. If you could mistake it, if my 3-year-old daughter might make this mistake, the computer's definitely going to make the mistake, right? That's the trick. Unresolvable blemishes, like you can only do a certain amount of text processing. You can only clean so much. My grandmother would say, you can't make a silk purse out of a sow's ear. So if you want that. I don't know what that means exactly, but she said it a lot, and when I told her about this, she told me that. So I'm telling it to you now. Just as proof of this, I actually ended up with a patent on some of this stuff around targeted optical character recognition for medical terminology. So one of the trick was, what we were looking for was medical terminology. So we could correct these errors with high accuracy for long words. So it turns out a lot of the stuff we were looking for were diagnoses, and diagnoses are things like atherosclerosis, right? Atherosclerosis is a much longer word than Bob, right? Bob is hard, atherosclerosis is pretty easy because there's a lot more information there. So the longer the word, the easier it is to correct, right? So most of these things end up being a domain-specific type of correction in general. But you can get pretty far, right? Especially documents that are over the internet. Like, I was really surprised at how cleanly Hillary's emails came in and how much she talked about Syria. She loved talking about Syria. Anyway, so follow us on Twitter, ask us questions. The source code is open. It's freely available. Go download it, go use it.
So we have a few things out there actually. The project should be really, really easy to use. It's Mavenized. We've got the templates that we use in this example uploaded in there as well for NiFi, so you should be able to do the entire thing soup to nuts pretty simply. I think the documentation is even there to some extent as well. All the custom processors for NiFi, it's all out there. Free, open, check us out on the GitHub page.
Yep. So now we can open the floor to questions. Yeah.
So I have a lot of questions, but
so many questions. Well, I'm answering none of them.
We'll start simple. So this is not a new problem that you guys have solved.
Nope.
You could pay IBM or Kofax or EMC a lot of money for a platform to do all of this, and the way that all of those platforms handle the 15% error rate, which is about where you're getting on OCR, is manual intervention by a low-skill user.
Mm-hmm.
Do you see an easy way to integrate some sort of user interface to do that kind of work in the NiFi workflow? And have you tried to integrate any of the handwriting recognition modules?
No. So the question is, what happens about the stuff that's bad, right? Which is around 15% of the errors, right? So if you go to a lot of the vendors who are going to come in and they're with an army of consultants, they're going to say, humans need to correct these things. There needs to be a loop. So in building any data pipeline, you should build in feedback loops, right? The way that we handled that in medical was we made the problem more specific, right? By making the problem more specific, you take that 15% error code or 15% error rate and drop it dramatically, because we were only looking at diagnoses, right? That's one way to solve the problem. If you can do that, do it. If you can't do that, then what you want to do is you want to actually build a pipeline where you're giving some sort of confidence. And what I've generally found, what I like to do in that situation is, we don't actually say that many distinct words as humans, turns out. If you have a lot of words in a document that are not used anywhere in like the Google Ngram project, you're probably going to have a fair amount of error. That's a good general error. I can filter that out. Also be able to be done in NiFi. And then instead of passing those into live, you pass those into another directory in HDFS for human intervention, and then manual correctness, possibly, So either correcting the problem in the image to make it easier to OCR, or actually transcription, which is a fairly good approach. And it keeps humans in the loop, which I love. It's my favorite way of doing big data.
So one of the other things we can do here, depending on, the emails, again, came in pretty cleanly, but there are other types of data sources where, let's say, someone scanned in a notebook. So you've got, edges that, if that gets, it's only going to get so well cleaned up with image magic, but then Tesseract is going to choke on that. You're going to get J's and L's and random things like that strewn about your text. So you can do, if you have, depending on the source, if it's fairly consistent like that, you can also do certain type of cropping and things like that. So we didn't include that here, but that's additional stuff that you can add to your pipeline with the pre-processing phase.
Yeah, intelligent cropping is one of the things I want to add on top of Fred's scripts, right, actually. It's one of the things that I'm particularly interested in. Yeah, question?
Were you using Yarn to run any of your image magic or Tesseract stuff? Or was that all?
This is entirely a NiFi. Obviously when we were using in the various other technologies of Hadoop, it works well within Yarn. One of the things we try to do very hard here was, while this is a NiFi talk, there's a very clean separation between NiFi and the individual processes. This could easily be transformed into a Hive. You could use Spark right now to do that if you don't want NiFi. But I actually found NiFi to be it's a really nice interface, a really nice way to do that. But it's totally separated out, right? The way the project's structured is each of the different phases have their own project, and then there's like a NiFi project. What eventually we'll probably do is have like a Spark project or a Pig project, stuff like that.
Yeah.
Yes?
How does Tesseract deal with non-character images? Does it just leave a space, or do they come in as is?
Yeah. So the question is, how does Tesseract deal with non-character images? What you're going to get is you're going to get a bunch of garbage, generally. But what you do, remember that part where I said there's more to this? You can generally tell when a line is garbage, right? Because it looks like it's very high entropy. So there's further types of things you can do to filter out the bad stuff. So I never do a presentation at Hadoop Summit where I don't do some data science. I didn't show you guys the data science, but I built like a topic model around Hillary Clinton's emails, just for my own interest, so I'm a geek. A reason why I wanted to do this is I wanted to make sure that we were clear on that, because there are some images in there. And so figuring out how to pick those out, it's not too hard for your normal data analysts. So there's more to it, but this gets you 80% of the way there, let's say. Yes?
So if you have something like an invoice, which is kind of like data organized in a tablet,
Yeah.
what happens with this?
Yeah, so the question is, what happens if your data is structured in terms of like an invoice? Then you have to do a lot more pre-processing. But if your data is coming in, so the radiology reports were a similar situation, right? We didn't just get radiology reports. We got diagnosis. We just got tons of crap, right? So the first step that you do is you classify which kind of crap it is, and you handle those specifically, right? This is to get you to the point where you can actually crack the nut, right? Then comes the hard work of actually figuring out how to pick the pieces apart. So what we ended up doing was, we knew that there were 4 or 5 different types of forms that these radiologists were using. And they really that's a data investigation phase. We knew how to pick it apart, because they were all, thankfully, the nice thing about forms is they're consistent, right? So I can actually make decisions about that. So once I figured out which kind of form it is, I can have custom logic to pick apart the pieces that I want. Right? And again, you can, which is, like a machine learning classifier, this kind of thing, right? And again, I know the kinds of text that I'm looking for, and I know the kind of text that's static, right? So use all the advantages that you can about this. Don't come at this as a general problem. Always cheat. If you take anything away from this talk, always cheat. Always. Use any advantage that you can. Information is an absolute advantage. Organization is an advantage. Use them to the hilt. Don't solve a general problem where you can get away with solving many smaller specific problems. Because Hadoop is really good at solving many small specific problems at the same time. Okay, any other questions? I was promised many questions from this guy. He gave me like one.
That's good one. Okay.
Section 2.
Oh boy. Obviously I've built these kinds of systems
Yeah.
before, but never on a Hadoop-based platform. So how did you go about building a classification engine when you were doing it in let's say Pig or Hive or something like that?
Yeah. So how do you pick it apart? How do you figure out the organization? So it's a very data sciencey problem, unfortunately, right? So topic models help, I would say, right? But actually I like to do TF-IDF. Like what are the dominant words here? And you can generally find patterns there where this kind of document's going to have these kind of dominant words, especially when you're getting disparate sources, right? So radiology reports are very different from discharge summaries. Discharge summaries about I went to the hospital, I had these things happen to me. Radiology reports are generally about I looked at this CT scan and it looked bad. This dude has lung cancer, which is terrible, right? Very different types of documents. So they really were very disparate. So k-means clustering helped a lot on that. It turns out that that was a fairly good approach to picking these things apart. Topic modeling was good. So generally the general kind of grab bag of unsupervised learning helps a lot in those kinds of situations. And then that feeding into more of the supervised learning once you get some examples, right? The general kind of data science pipeline that you see. Unsupervised learning for data investigation followed closely on supervised learning for data classification. Okay, well, if there's any other questions, you guys can give your 8 minutes back. You can come up to the stage.